Hello everyone. So here we have a very simple set based on the Minesweeper game. Hopefully some of you might have played the Minesweeper game. So what is the game? Let's see. Minesweeper is a game played on a 8 by 8 matrix. The columns are numbered A to H from left to right and rows are numbered from 1 to 8 from top to bottom. Okay. So columns are A, B, C, D, E, F, G, and rows are 1 2 3 4 5 6 and so on. Okay, so A in bth column and fifth row is termed as B5. It should be a cell in bth column and fifth row is termed as B5. Okay, so what's happening is, let's say this is your 8 by 8 matrix, right? So these are the columns and these are the rows. Okay, so B5, this particular cell is in bth column and fifth row. So this cell is termed as B5. If we, let's say, pick up this cell would be termed as E3 because it is in eth column and third row here. Okay, so this is what it is. Now let's look at the rules of the game. There is a mine in one of the cells. Okay, if a player clicks on any of the cells in the same column, row, or any diagonal as the cell with the mine, the player will lose. Okay, so let's say this cell has a mine. If this cell has a mine, so in case a player picks any of the cells in the same row, let's say if he picks this cell or this one, if he picks any cell in the column, he or she will lose the game, right? If he picks any cell in the same row, then also he or she will lose. If he picks any cell in the same diagonal, then also the player will lose, right? So if this cell has a mine, the player choosing any of these black colored or the red colored cells, the player will lose. Okay, now the player has to click on all the safe cells to win. Okay, the player has to click on all the safe cells. Now what is a safe cell? Safe cells are those cells which are neither in the same column, row, or any diagonal as the cell with mine. Okay, so what this means is, let's say if this is a safe cell, this can be the safe cell only if there is no mine in the same column, row, or diagonal. So there should not be any mine here, or here. There should not be any mine in the same row as well. There should be no mine in the same diagonal as well, and no mine in this diagonal as well. So if this is a safe cell, there would be no mine in the same column, row, or diagonal. Then only we can term this as a safe cell here. Okay, so the game is designed such that the first two clicks by a player are always safe and the mine is placed accordingly after that. So when you start the game, initially what's happening is you don't know where is the mine, and actually there is no mine placed initially for the first two clicks. So the first two clicks by the player will always be safe. Let's say if a player clicks on this cell, and this cell will reveal whether it has a mine or it is safe. So the first two clicks will always be safe. So let's say if this is the first click, let me say C1, click 1. If I click this particular cell, it will be a safe cell. Since this is a safe cell, that means the same column will have no mines, the same row will have no mines, and the same diagonals will have no mines. And let's say if the second click is somewhere here, if this is the second click, in that case this is a safe cell, so same row will have no mines, same column will have no mines, and same diagonals will have no mines. These will be the diagonals for this cell. So now if a mine has to be placed, it can only be placed after the first two cells, which the game automatically will do. So now if these are the first two clicks, first is this one, second is this one, if these are the first two clicks, then mine can be placed in any of the remaining cells. These are the remaining cells. Mine can be placed in any of these cells because none of these cells is a safe cell, or rather, since these are the two safe cells, mine cannot be placed in any of these green and the blue cells. Mine can only be placed in the red cells over here. These are the rules of the game that we have. Now let's look at the questions. The first question is, what is the difference between the maximum and minimum number of safe cells? So if we want maximum number of safe cells, we should place the mine such that minimum number of cells are affected by it, or there are minimum number of cells in the same row, column or diagonal. So as far as row or column is concerned, if you place a mine over here or over here or over here, the number of cells in the same row or column will be same, right? If you place a mine, let's say here, if you place a mine over here, the number of cells in the same column will be these 7 plus these 7 in the same row. So 7 plus 7, 14. Even if you place a mine over here, number of cells in the same column will be 3 plus 4, 7, and in same row will be 3 plus 4, 7. 7 plus 7, again 14. So the number of cells in the same row or column will be same wherever the mine is. So what we need to do is, we need to minimize the number of cells in the same diagonal, right? Now, how can we minimize or maximize the number of cells in the diagonal? See, if we put a mine over here in this particular cell, that is somewhere in the middle of the board, you will have 1, 2, 3, 4, 5, 6, 7 cells in this diagonal, and 8, 9, 10, 11, 12, 13 cells in the other diagonal, if you place the mine somewhere in the middle of the board. But if you place the mine exactly at the corner, there will only be one diagonal, isn't it? The number of cells will be 1, 2, 3, 4, 5, 6 and 7. There will be only one diagonal, there won't be any other diagonal. So the number of cells in the diagonals will be minimized when the mine is placed somewhere in the corner, in any of the four corners. So let's say this is the mine over here. If this is the mine, these cells are not safe cells. The cells with a cross mark are not safe cells. These are unsafe cells. So this is in the same column, this is in the same row, and this is in the same diagonal. How many unsafe cells are there? 7 plus 7, 14, 14 plus 7, 21, 21 plus this cell is also unsafe cell, 22. So out of 64, 22 are not safe. So safe cells are 42, and this is the maximum number of safe cells because we have minimized the unsafe diagonal cells here, right? This is the case when the mine is placed exactly in the corner. If mine is somewhere in the middle, these are the four middle blocks here. There is no single middle block. There are four middle blocks or four middle cells. So you can place the mine in any of these four cells. The number of unsafe cells will be same. If mine is placed here, the column cells will not be safe. They will be unsafe. The row cells will be unsafe, right? So we have 7 plus 7 unsafe cells in same column or row. 7 plus 7 is 14 plus 1 mine, which that gives me 15 cells unsafe so far. Now let's count diagonals. 15, 16, 17, 18, 19, 20, 21, 22. Then you have the other diagonal 23, 24, 25, 26, 27, 28. So there are 28 unsafe cells. So you'll have 64 minus 28, which gives me 36 safe cells, and this will be the minimum safe cells that we have. So your final answer is the difference between maximum and minimum safe cells. So the difference between maximum and minimum safe cells will be 42 minus 36, which gives us 6. Hence the answer to this question is option B, 6 here. Okay. Now moving on to the next question. Here we have, if the first two clicks are A5 and G2, while the third click C3 is also safe. Now we know the first two clicks have to be safe. So A5 and G2, where is A5? This is A5 and G2. We have G2. These two are safe clicks. So let's go one by one. Now A5 is a safe click. That means there would be no mine in the same row, column or diagonal of A5, right? So we would have no mine in these cells here, no mine in these cells here, no mines in these cells here. All these are safe cells. All these are safe cells because A5 is a safe cell. Now G2 is also a safe cell. Since G2 is a safe cell, there would be no mine in the same column or in the same row or in the same diagonal. Fine. Now the third click C3 is also a safe click. So C3, this here is also a safe click. Now since this is a safe click, there would be no mine in the same row, column or diagonal. So there will be no mine here, no mine over here, no mine in the same diagonal, and no mine in this diagonal as well. Okay, so there are no mines over here. So mines can only be in the empty cells right now. So in how many ways or in how many cells mine can be placed now? Let's see. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So there are 14 cells in which mine can be placed. So the answer to this question is 14 here. Okay. Now let's move on to the last question. Here we have the first two clicks are D4 and H7. We know the first two clicks have to be safe. So D4, this is D4 here, and H7 is this. So these two clicks are safe. That means there would be no mine in the same column, row or diagonals. So these cells in black will have no mines. Similarly, since this is a safe click, there would be no mine in the same column, row or diagonal. For this, let's consider the diagonals. This is the diagonal 1, this is the other diagonal. For this, the diagonal is this one here, this one here, and this would be the other diagonal. So we have marked all the safe cells so far. So how many unsafe cells are there, or rather how many cells are there in which mine can be placed? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. So there are 21 cells in which mine can be placed. Now we have in how many ways two different mines can be placed in each. Mines can be placed each in a different cells. There are 21 cells and we have to place two mines. Let's call the two mines as M1 and M2. M1 and M2. So the first mine M1 can be placed in 21 ways, right? Because there are 21 cells, first mine can be put in any of these 21 cells that are marked in red. Now once the first mine is placed, the number of cells remaining is 20. So the next mine can be placed in 20 ways, in 20 remaining empty cells, because both the mines have to go in different cells, right? So the total number of ways will be 21 into 20 ways. So 21 into 20 will give me 420 ways. So the two mines can be placed in a total of 420 ways. Hence the answer to this question is 420 here. Okay, so that's it for this set. Thank you.